Let's okay, there's some other stuff in this section 3.3. Let's stop this for a minute. The library of functions. There's this general thing here in 3.3. There's these piecewise functions, and I got some of these in the homework. I don't really want to make this too difficult. I'd like to do this kind of at a lighter level. Maybe the next class you can do this at a deeper level. But it's piecewise function. Watch this. This function equals 2 when x is less than 4. And then it equals 5 when x is greater than or equal to 4. It's called a piecewise function. It is defined in pieces, as you can sort of tell. I mean, look at the two pieces. There's that, look, when you look at a piecewise function, your brain ought to go over here first. You ought to look at, I mean, I think you need to go here first and realize, okay, so when x is less than 4, it's one thing, and when x is greater than 4, it's another thing. That's the two pieces. Now on a graph then, and I think there is a little bit of graphing going on here, but you know, some of it on the homework is multiple choice, but I mean, I don't know, I guess it's cooler. It's easy to kind of talk about this graph. Like I said, my brain goes here first. I think you should go look over here first and say, okay, 4 seems to be the place where everything changes. Now, so what's going on when x is less than 4? When x is less than 4, this function is a 2. By the way, that's just y equals 2. Do you know how to draw y equals 2? Maybe we never drew that. It's a line. It's just a horizontal line. It's y equals 2. It's so simple that, again, some of this simple stuff blows students away. It's called y equals 2, and it looks like this. And I'm doing that for all x values less than 4. For x values less than 4, I'm a 2. For x values greater than 4, I'm my y value is 5. Okay. Starting at 4 and to the right, my y value is 5. So this is a picture of a piecewise function. It first of all, it's discontinuous. It has a discontinuity where it's not continuous. It has a big break in it. It breaks and jumps up here. I mean, that's what a piecewise function might do. Sometimes your piecewise functions join up together. These are discussed, you know, a lot in calculus, at the beginning of calculus a little bit, and maybe some pre-calculus. Like I said, I don't want to go too far with these. I gave you real simple ones here. Just a little detail here, though. Let's see. If I was plotting points, you know, what if I asked you this question? Sometimes this is a cool question on a test. I give you a piecewise function and I say, what's f of 3? And that means you're plugging in a 3. I mean, you gotta know how to read this math. And so your x is a 3, you're plugging in a 3, and if you're plugging in a 3, don't look at that yet. My brain would go here and say, okay, if I'm plugging in a 3, I guess I'm less than 4. If I'm less than 4, the answer is 2. What if you plugged in a 3.9? The answer is 2. What if you plugged in a 3.9999999? That's a 2. What if you plugged in a 4? If you actually plugged in a 4, then I should pay attention to where it says it equals 4. Here, see that equal to sign? And therefore, I'm equal to 4. And when I'm equal to 4, I'm falling into this piece of the piecewise function. And the answer would be 5. Of course. I mean, I'm helping you read this. It's not that hard, but students get a little confused sometimes. Hey, so just for this detail then, when you do plug in the 4, where are you? You're at the 5? You're not here. So I'm going to put a little open circle here because this line comes up here and at 3.99999 it's at 2, but at 4 it's not at 2. So I put a little open circle. Up here, though, I'll color that one in because at 4, it is 5. So one of these is open, one of these is colored in there. See, that makes it a function. Look, what if they were both colored in? See, then it's not a function because it fails the vertical line test. Look, it doesn't fail the vertical line test here, but right there, it hits it twice. You know? So we don't have that. We got, sorry. We got, this circle is open. Look at this one. Look at this one. It equals 1 when x is greater than or equal to 0 and less than 1. It equals 2 when x is greater than or equal to 1 and less than 3. It equals 3 when x is less than or equal to, greater than or equal to 3, but less than, that's it. This is another easy one. Now listen, I could ask you to graph it. If the homework asks you to graph it, it might be multiple choice. You get to pick which graph it is. But to figure that out, you might have to kind of graph it on your own. But forget graphing for just a second. I could just ask you stupid questions like this. What's f of 2.5? And you would say, okay, x is 2.5. Let me go read my directions. I feel like these are the directions. And so when x is a 2.5, you're here. And if you're in here, you are defined to be this y value, which is 2. Right? So it's just a matter of kind of reading these directions and putting the answer in the right place. Cool. By the way, very quickly, this guy's only defined between 0 and 1. Between 0 and 1, something's going on. Between 1 and 3, something is going on. And then greater than 3, something's going on. You can sort of see that? It's kind of 3 pieces. This was a 2-piece piecewise function. This is a 3-piece piecewise function. So what is it? Between 0 and 1, the y value is 1. Between 1 and 3, the y value is 2. Greater than 3, the y value is 3. I'm good at reading these. I'm just reading it quickly and doing what it says. Between 0 and 1, what's the y value? 1. For x values between 1 and 3, what is the y value? 2. For x values greater than 3, the y value is 3. If we want to pay attention to the details, we could pay attention to where these equal signs are and shade in the appropriate dots here. That wasn't really my point, but let's do it, I guess. So when it's equal to 0, that should include the 1. I think there's kind of colored in there, but I think it's not colored in there. Do you agree? But when it does equal 1, then the y value is 2. Oh, so when it does equal 1, this y value of 2 should be colored in, and probably this end is not. And then when it equals 3, when x equals 3, the y value is 3. So this guy's colored in. Yeah, this guy's not. Right. There's a few word problems in the book. I assigned in the homework. There's a few word problems involving these, and I assigned them. I'd like you to think about them and try to figure them out. They look kind of complicated, but they're not that hard. I'm not going to go over them now. I'll let you go over them. Let me do one more difficult piecewise function here. Look at this one. It's negative x when x is less than 0. And it's positive x when x is greater than or equal to 0. If I asked you to draw this, then maybe you would plot some points. Let's start with the second piece here. Let's not start up there. Let's start here. What is this? F of x equals x. Can you tell me what that is? Like, is it a parabola? Is it a cubic equation? It's a line. Am I right? F of x equals x is a line with a slope of 1. I mean, forget that. I can plot points. If you plug in a 0, you pay attention to the equal sign. You plug in a 0, and what do you get? 0. Plug in a 1, what do you get? 1. Plug in a 2. I'm plugging in positive x's, and what do I get? 2 and 3. And this is this line. What about for these negative x's? For these negative x's, if you plug in a negative 1, right, you would plug it in here. What is negative 1 with a negative sign in front of it? 1. So I'm plugging in a negative 1, and I just got a 1. Plug in a negative 2, and the negative sign makes it positive 2. And you get this line with a negative slope. This is a line with a negative slope. This is this line with a positive slope. You know what this is? I had this on the board a few minutes ago. This is my absolute value function, actually. My absolute value function is negative x when x is less than 0, and it's positive x when x is greater than 0. Okay. All right. You know what? I think I'm going to quit today. I'm kind of happy, but the truth is, in 3.3, there was something I didn't get to yet, but I'm not going to do it now. It's called variation. I can work on direct and inverse variation. That's not a real hard topic, but it needs to be discussed. It's at the end of 3.3. But I'll do that next time, probably. And then 3.4 is pretty minor. There's an idea or two in 3.4, but otherwise, we're close to the end of this chapter as far as lectures go. As far as you working on homework, you might have some work to do. And I'll help you with some homework next week. But we're going to do a quiz next class. Quiz Tuesday. An in-class quiz. All right, thank you guys. See you.